Safely managing used nuclear fuel in Canada. When uranium is mined from the ground, it is not directly usable to generate electricity. The uranium must first be processed before it can be used in a nuclear reactor. A chemical process is used to extract uranium from the ore. The procedure creates a uranium concentrate known as yellowcake. Impurities are removed from the yellowcake, and the uranium is converted back into solid form, ready for further processing. It is ground into a sugar-like powder, which is then pressed into pellets. When the pellets are baked, they take on a hard ceramic form. The ceramic fuel pellets are packed into pencil-like tubes made of zircaloy. 27 to 38 of these tubes are welded together to form a fuel bundle. The fuel bundles are then inserted into the core of CANDU reactors, where a controlled nuclear reaction occurs, producing heat. The heat that is generated is carried away by water to a secondary circuit where steam is created to drive turbine generators, which produce electricity. The steam is then cooled, condensed back into water, and returned to the steam generator, where it is circulated again. Canada has accumulated about 2 million used fuel bundles since the beginning of its nuclear electricity generating program in the early 1970s. Stacked like cordwood, all of these could fit into 6 NHL-sized hockey rinks, from the ice surface to the top of the boards. After approximately 18 months in a CANDU reactor, used fuel bundles are removed and placed in water-filled pools for 7 to 10 years to reduce their heat and radioactivity. The fuel bundles are then transferred by remote control underwater into large concrete and steel dry storage containers. The dry storage containers are moved using a specially designed vehicle from the reactor building to a nearby facility on site where they are welded shut. The containers are then placed in licensed facilities at the nuclear generating stations. This storage is considered interim and is not meant to be permanent. Canada's plan for the long-term management of used nuclear fuel has as its endpoint a deep geological repository hosted by an informed and willing community. The centralized facility will require a land area of about 250 acres or 100 hectares. Surface buildings to receive and package the used fuel will use a small portion of the total site. After they arrive at the central facility, used fuel bundles will be placed in copper and steel containers that are designed to last at least 100,000 years and manufactured to protect against corrosion and to withstand the pressure of glaciers with an ice sheet over 2 kilometers thick. The repository will be constructed approximately 500 meters below ground, depending on the geology of the site itself. Once delivered underground, the containers will be transferred along a network of horizontal tunnels to rooms excavated in stable rock. They will be placed in boreholes drilled into the floor or within the excavated tunnels themselves. The sealed containers will be further protected by a barrier of swelling bentonite clay. The final and principal barrier between the used fuel and the surface environment will be the surrounding host rock. Adaptive phased management provides for the used fuel to be monitored for an extended period of time to confirm the long-term safety and performance of the repository system. And it will remain retrievable until a future generation, perhaps 100 years or more from now, decides to backfill and seal off access to the repository and decommission the facility.